Hi there, Mr. Holcomb here with another episode of the Math Behind the Modules. This is Lesson 21, Surface Area. Opening exercise, surface area of a right rectangular prism. Right tells us that each angle on each surface is 90 degrees. This is 90 degrees, 90 degrees, 90 degrees. Doesn't matter from the top, bottom, left, right, front, back. Each angle is 90 degrees. So that's right. Rectangular meaning each face is in the shape of a rectangle. And a prism just means a 3D figure in that shape. So that's what a right rectangular prism is. So let's take a look at this first question. On the provided grid, draw a net representing the surfaces of the right rectangular prism. Assume each grid line represents 1 inch. Then find the surface area of the prism by finding the area of the net. Okay, so a net is a figure that we fold or unfold. So if I were to cut this, picture a box being cut apart and laid out flat. So the front, back, top, bottom, left, right are all visible. Okay, so I have a 3-inch, so I'll start with the front. And let's see how much space I have. Let me minimize this just a moment. Okay, I just wanted to zoom out so we could take a look at all of this. So I have a rectangle that's 3 by 6. So if I look at the front, I'm just going to do a sketch here. This is 3, and this height is 6. That's the front. That's a 3 by 6 rectangle. The side, the right-hand side, is 4 deep and 6 tall. So if I laid that out flat, if I cut this box apart, the right side is 4 by 6. The back is going to be the same as this one, so this will be behind that we can't see, and that will be 3 by 6, and this will be on the left side, over on this side that we can't see, and that is going to be the same size as the other, which is 4 by 6. Okay, so this is 3 and this is 4, so my top is going to be a rectangle that is 3 by 4, and the bottom is also going to be 3 by 4. So if I cut this all out, it was all connected, then my net would look something like this. So let me be really neat about this, and I will use a ruler. It's really hard to draw straight lines with just this pen, so I'll bring this down. Okay, so bear with me because in math we need to be precise. Precision is very important. And I am going to start off with my left piece. This is my left piece. This was my front. This was my right. And this was my back. And this is my top. And this is my bottom. Front, right, left. Front, right, left, back, top, bottom. Is that correct? 3, 6 front? No. This is my back. Same size as the front. This is the back. This is the left. Right, left, front, back, top, bottom. Okay. So if I were to cut this out and lay it out flat, picture this left side getting folded around. We'll start there. We'll start with the left piece, which is right here. It's 4 by 6. So I'm going to start right here. Draw a line of length 4 and go up 1, 2, 3, 4, 5, 6. One, 2, 3, 4. Rotate it. Okay, so there is my left side, and I'll label it left. I'm going to change colors for the front. So now we're looking at this piece right here, and that's 3 by 6. So I have to go over 1, 2, 3. So this front piece is here. and it lines up with this. So this would be our crease, our fold, if it was a box and we were unfolding it. And then this is 3. And this is 3. So that is the front. Okay, now I'm going to do the right in the same color as the left. So the right and left will be red. And now I'm going to draw another box that is length 4. 1, 2, 3, 4. Rotate. Okay. This is the right. Front. So we started with folding this piece out this way. Here's the front, here's the right, and then fold out the back. I'll use the same color, and that was 3 wide. So I'll go to here and draw a line. Rotate. Three. Bring down here. 3. And this is the other side, just to show that this is the back. So we have the left, front, right, back. Now let's connect the top. Let's say we're going to open the top towards us. So this will be the hinge that we're going to use. And it is 3 by 4. And I will use purple or blue, whatever this one is. So it's going to be the same width as my front and the same height as my side. So it's 3 by 4. So as you can see, there's 4 squares there, 4 squares here, bring this up, rotate it, rotate, there we go. Okay, we're going to do the same thing on the bottom. Let's fold the bottom out from there as well. So that's 1, 2, 3, 4. So a lot of students have difficulty with this because they don't have a lot struggle with the spatial recognition that this requires. Okay, being able to picture taking a box and unfolding it and seeing what it would look like in the finished product. Okay. Alright, so let's just move that there. So this is the top, and this is the bottom. That is what a net is. Okay, so this is a space of 4 by 6. This is 3 by 6. This is 4 by 6. This is 3 by 6. And this is 3 by 4. And this is 3 by 4. Okay, I can simply just count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But area is length times width, which is 3 times 4. So the top area is 12. The bottom area is 12. The left is 4 times 6, which is 24. If you want to take the time and count the squares, you'll get 24. 3 times 6 is 18. 4 times 6 is 24. And 3 times 6 again is 18. So it says find the surface area of the prism by finding the area of the net. So the area of the prism equals the top plus the bottom plus the left plus the right plus the front plus the back. Just showing all of my work. The top was 12. The bottom was 12. The left was 24. The right was 24. The front was 18. And the back was 18. So the area of the prism is 12 plus 12, which is 24. 24 and 24 is 48. 72. 90. And 118 is 108 units squared. It says assume each grid line represents 1 inch. So now I'm going to change my answer. Notice every time I finish a problem, I go back and read the question, and they told us that it was an inch. So my answer is not units squared, it is inches squared. So the area of that prism is 108 square inches. Okay, exercise 1. Exercise means it's your turn. Pause the video, see if you can do this, come back and we'll check your answers. Okay, this problem says Marcus thinks that the surface area of the right rectangular prism will be half that of the right rectangular prism and wants to use the modified formula. So what they're saying is he's cutting this rectangular prism in half, and he believes that the surface area of the half will equal half of the rectangular prism surface area from 4. So it's 3 by 4 by 6 by, then they cut it diagonally, and that is length 5. So we were working with the same problem before, so let's take a look again. 3 by 4 by 6. This is 3 by 4 by 6, and he drew a diagonal here and said it's 5 inches. Okay, well, if we know geometry, we know that that's a right triangle. And if there's a thing called Pythagorean Theorem that says a squared plus b squared equals c squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and 5 squared equals 25, so therefore c squared does equal a squared plus b squared. So this length is correct, I will agree with that. But now if we draw a net of this, I will first draw the base in the center, so it's length 5. So I need my ruler. So we are drawing now picture this getting cut in half, so the bottom now is a 5-inch, is a distance of 5 inches. But we already have a 3 and a 4, so let's just start with that. So we have a front. I just need to draw a sketch of this before we try to go any further. This is the front, and it's 3 by 4. Okay, this is the right side, and it's 4 by 6. And then we have the new back, which is a rectangle, and the length is 5, and the height is 6. Does everybody see that? This is 5, and this is 6. So if you look at this base as a rectangle, that's 5 by 6. And then finally we have these top pieces that are triangles that look like this. Okay? And we know that this is 3, and we know that this is 4, and we know that that's 5. And we have 2 of them. We also have the one down here. Okay? So now we have that one, which is also 3, 4, and 5. Okay, so there's my rough sketch. So what does it tell us to do? Thinks the surface area of the right rectangular prism will be half that of the rectangular prism and wants to use a modified formula. That is, surface area equals 1/2 2LW plus 2LH plus 2WH. Do you agree or disagree with Marcus? Use the net of the prism to support your argument. Okay, so if I make a net and I start with the front folded out, I'm trying to make sure I have enough space here to do this. I might have to shift everything. I'll draw it right here. It's length 3 by 1, 2, 3, 4. Length 3. Rotate. So I'm drawing the net accurately. Okay, so this is 3 by 4. And that is the front. That is this piece. Okay, this front square. And this one that's at an angle will be attached to it. I will draw that in red. And that is 4 by 6. Okay. Oh, not 3 by 4, I'm sorry. The front is not 3 by 4. I just realized something. It is 3 by 6. So I needed to go up 2 more. So let me fix that first. extend these up to there. Extend up to there. Okay, a little bit sloppy, but I don't want to spend too much time on this. This is 3 by 6, not 4. That is this piece right here. Okay, 3 by 6. 3 wide, 6 tall. That's the front. Okay. Now I'm going to switch colors, and now I have a 4 by 6. So if I go and draw a line here, that's the edge right here. And then I'm going to go over 1, 2, 3, 4. And draw a line that's 6 long. That is this line here. And then when I draw this line right here, that is actually this top piece. Maybe if I do it in order like this, it's helpful. And this is the bottom, here to here. So this is the right side, and it's 4 by 6. And then if I swing this back piece out, it is length 5 by 6. Okay, so now I'm going to use blue for that. And that is 1, 2, 3, 4, 5, up 6. Okay, so this 5 I just drew is up there. The one I drew first is this one down here. And when I rotate, drawing this side here is this. Drawing this side over here is the other one back there. So it's that gray. This is 5 by 6. Now, connected to this base right here is a triangle that is 4 by 3 by 5. So how could I draw that then? Okay, so let's just say it comes up to here. I want to draw a line from here. Move that right down to 0. Rotate it so it goes to there. Rotate it the other way. Do the same down here. And those are the top and bottom pieces, where this length is 3, this length is 4, this length is 3, this length is 4. So that should be a little bit longer over here. But you get the idea. So there is my net of this. Okay, so now if I want to find the area, surface area just means all the spaces added up. Let's get rid of all of this drawing here and start with what we have. This is 3 by 6, which is 18. This is 4 by 6, which is 24. This is 5 by 6, which is 30. This is a right angle. An area of a triangle is 1/2 base times height. So if I wrote this formula, I'd say surface area equals LW plus LW plus LW, right? Length times width of the front, length times width of the right, length times width of the bottom, plus 1/2 length times width for the top triangle, plus 1/2 length times width of the bottom triangle. And these are going to be equal. And 1/2 plus 1/2 is a whole, so that's going to just simply equal the length times width of this. I will show all my work rather than breaking it down first. Just trying to explain everything out here. So the surface area is length 3 by 6 plus 4 times 6, 3 times 6 plus 4 times 6 plus 5 times 6 plus 1/2 3 times 4 plus 1/2 3 times 4. So this is going to equal 18 plus 24 plus 30 plus, well, half of 4 is 2, 3 times 2 is 6, half of 4 is 2, 3 times 2 is 6. So I add all of those up and I get 18 plus 24 is 32, plus 3 is 62, plus 6, 68, plus 6, 74 inches squared. I paused because I needed to look at what we were measuring in, and it is inches. So it's 74 square inches is what this net is. And if I go back, the question's asking, is it half? Well, half of 108 is 54. This is 74. So do you agree with Marcus? I would say no. The surface area is more than 1/2 original. Okay, the surface area is more than half the original. It's not the same. Because if we're going to cut this in half, we take half of the surface area off, but then we're adding this backside, which was 30. Okay, so as I had this video paused, I was looking over my work and I made a mistake on these labels. It does not change the problem in any way, shape, or form. The values are all the same, but if this is a length of 4 and I fold it up, it is going to have to match this side. I had a 3 here when it actually should be a 4, and the 3 side's over here. So the 4, this red, this folds up and the red folds up to it, that's 4. This 3 would flip over the other side at this peak, and the 3 would be on this side. So I just had the 4 and the 3 reversed, which would give the same triangle rotated, and this way it would line up. Okay. Okay, now example 1, lateral area of a right prism. Okay, so now we have a triangular prism, a rectangular prism, and a 6-sided figure, a hexagonal prism. Hexagon, that's 6. That's a pentagon. Pentagon, 1, 2, 3, 4, 5. That's a pentagonal prism. Pentagon. All right, so anyhow, they're talking about, what word have we not seen before? Write an expression that represents the lateral area. Lateral means side. They don't mean the base on top or the base on the bottom. So if you see this triangle down here, that's the bottom. We aren't going to count that. And if we see this triangle up here as the top of this, we aren't going to count that. So if I go back to my last problem, my lateral area would not include this triangle or this triangle. My lateral area is simply the 3 rectangular sides that form this shape, the height of it. So it would be this rectangle plus this rectangle plus this rectangle, which, looking at the diagram, is the sides around, but not including these 2 triangles, top and bottom. Okay, so that is lateral area. So let me erase these, and I'll try to color code these so you can see what I'm talking about. So we're looking through the figure, and a lot of students have difficulty with this, but this is the back side that we can't see on the left, and that is a rectangle with a base of A and a height of H. So the expression that represents the lateral area for that piece would be A times H. And if we're going to find lateral area, we add up all the sides. So that's going to be plus. And then now I need this back side on the right, which is this piece that we can't see unless we can see through it. So the side back here is B, and the height is H. So that would be B times H would be the area of that rectangle. And then finally the rectangle facing us right in front, staring us in the face, is C and height h. So that would be plus C times h. Okay? And now we want to do the same for the next two. So when I go to the next page, it says write an expression that represents the lateral area of the right rectangular prism. Write an expression that represents the lateral area of the right pentagonal prism. So they're asking the same thing on all three of these, and so I don't have to go back and forth over and over again. I will just do it right here. Okay? They have a tendency in this book to like to start a problem on one page and finish it on the next, and that just doesn't always work so well. So here we go. So if I do the left side first, so I'll just erase as I go so it's not too confusing. So that is that side, and that is the same as B. So I'd call that length B and that height H. So it's B times H, but if you see the opposite sides of this box are going to be congruent, B times H again. So I can just simply say 2 B times H. That's the left and the right. Okay, so now let's do the front and the back. So the front, staring us right in the face again, is this one. Okay, and the one behind it's right here, offset a little bit, but the same size as the front one, right? So if I just move this one out of the way, so this is the same as this one, and they're A wide, H tall. So that would be plus 2AH, okay, because this is A and this is H. So the area is A times H, and there are two of them, front and the back. And then finally we do the last piece, and that is the top and the bottom, which is this piece here and this piece here. Okay, and that's A by B, so that's going to be 2AB. Okay, so that's the expression for that one. Okay, so now we'll move on to the next one. House here a little bit. Okay, so now the lateral surface area, okay, lateral area of its faces does not include the pentagon base or the pentagon top. It's the 5 sides. So let's start with this, and that distance is B, and the height is H, and then there's side A, and then there's side C, and then there's side D, and then there's side E. So if it's the base B, and the C would also be down here, and the D would also be down here, so we go A, B, C, D, E, alphabetical order. So it's the base length times the height H, and the H is always the same. So it will be side A, which is in front of us, times H, plus side B times H, plus the length of C times H, plus the length of D times H, plus the length of E times H. Okay? So AH plus BH plus CH plus DH plus EH. Okay. Alright, next problem. So I did B and C already, just in the first page. So D, what value appears often in each expression and why? And the answer is the height. I don't know how to spell height. Height, H-E-I-G-H-T, repeats for every rectangular piece. Rectangular piece. Okay, the height repeats for every rectangular piece. Okay, that's a little more legible now. I'm amazed this computer program can read my writing, but anyway. E, rewrite each expression in factored form using the distributive property and the height of each lateral face. So let me bring those down, and we will work that. Okay, so I brought these back in. I copied them from the last page. It says rewrite each expression in factored form, so when they have an H in common, that would equal H times the quantity A plus B plus C. And if I factor out the common factor here, it's 2. Each has a 2. Each has an h. That's an h, not a b. So I can factor out an h from everyone, and I'm left with b plus a plus, oh wait, that is a b. Take that back. The only thing I can factor out of this is 2, leaving me with b h plus a h plus a b. All right. So that is the 2 factored out. This one has an h, 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 so I can factor out an h, leaving a plus b plus c plus d plus e, and that is factored for. What do the parentheses in each case represent with respect to the right prism? A plus b plus c. It's the sum of the sides of the bases, sum of the base of each prism. Okay, the sum of the sides of the base of each prism. How can we generalize the lateral area of a right prism into a formula that applies to all prisms? Okay. Well, what are the sum of the sides of a base? I believe that's called perimeter. So I would say LA for lateral area equals the perimeter of the base times h. Okay, there it is, a little bit more legible. Lateral area equals the perimeter of the base times its height. Okay, relevant vocabulary, right prism, cube, surface, net, all this stuff. Why are these lateral faces? Always rectangular regions, and so on and so forth. I'm going to leave that for you, and that is the end of the lesson. 21, go do your problems.